Okay. Okay, good morning all of you. From today onwards, we are starting a new unit, that is frequency modulation. Okay. Before starting this topic, first we have to know what is the meaning of modulation. We already covered modulation in our second unit. Okay. First of all, define what is modulation. Anyone? What is modulation?
लो एनर्जी और लो फ्रीक्वेंसी सिग्नल को मिक्स किया जाता है हाई एनर्जी हाई फ्रीक्वेंसी सिग्नल हाई एनर्जी
When we need to transfer any low frequency signal in a large distance, so it is impossible. So at that time, we merge a high frequency signal with the low frequency signal. The superimposing the property of high frequency signal to the low frequency signal is known as modulation. Okay. In other words, in ideal words, in technical words, modulation is defined as modulation is a process. Modulation is a process in which some parameters of carrier signal is changed according to modulating signal. Clear one? Some parameter of carrier signal is changed. How many parameters are there in any continuous signal? Which one?
frequency amplitude
Good. When I represent any signal, by using some mathematical expression, so I can represent any signal by using its amplitude and angle. Okay, this angle is again divided into two parts. This angle is again divided into two parts. First one is the frequency. Clear? Now the second one is phase. Is it clear? Angle is the combination of frequency and phase. By combining the frequency term with the phase term, we will get the angle. Okay, so there are the three different parameters of any continuous signal. First one is amplitude, second one is frequency, and third one is phase. By combining frequency and phase, we can say angle. Okay, so when I change any parameter of carrier signal, in these any one of carrier signal will be changed and other two will be constant. Okay, so when I changed the frequency of carrier signal, at that time amplitude and phase are constant. Clear one? When I change phase of carrier signal, at that time amplitude and frequencies are constant. Okay, and when I change amplitude of carrier signal, at that time frequency and phase are constant. Is that clear? So modulation is a process in which any one parameter of carrier signal is changed according to modulating signal, and at that time other parameters are constant. Okay. Now, when we discuss amplitude modulation in the second unit, at that time, what is the definition of amplitude modulation? What we have discussed here. What is the definition of amplitude modulation? Amplitude modulation is the process in which parameter of carrier signal? Amplitude of carrier signal is changed according to modulating signal, and at that time other parameters, that is frequency and phase, are constant. Is it clear? Now, in this unit, we are discussing the frequency modulation. In this unit, we are discussing the frequency modulation, and this second unit, is also known as the angle modulation. This second unit is also known as angle modulation because in this unit we will discuss the frequency modulation as well as phase modulation. So by combining the frequency as well as and phase, we can create angle modulation. Clear? Okay. So first, what is the definition of frequency modulation? Frequency modulation. In frequency modulation, frequency varies according to modulating signal, and at that time phase and amplitude are constant. Is it clear? Okay. This one is the massive signal. I am representing a waveform. This one is the massive signal. This one is the massive signal. Here x-axis represents time and y-axis representing amplitude. I am representing amplitude as A. Okay. Now, this one is the carrier signal. Whose frequency is higher? Whose frequency is higher? The frequency of massive signal is higher or the frequency of carrier signal is higher? Is it clear? This one is the message signal. It is represented as MT. Okay, because I am representing the message signal in time domain. This message is the mathematical expression of this message signal MT equals to AM cos of 2 pi FMT plus phi. We can also written phi here. But because in amplitude modulation phase is constant, so phase is constant, so it is not required to represent phase everywhere. Okay, so that's why I am representing message signal as AM cos 2 pi FMT. Now we know that the frequency of carrier is higher as compared to message signal. So if the frequency is higher, so the time required to complete one oscillation will be. If frequency is high, then time will be low. Okay, so this one is the time required to complete one oscillation. Is that clear? So if frequency is higher, so this time required will be low. So if I am representing the carrier signal, so the carrier signal will look like this one is the carrier signal. This one is the carrier signal. So what is this amplitude? The value of this amplitude is plus AC, and the value of this amplitude will be minus AC. Is it clear? Okay. So the x-axis representing time, and mathematically it is represented as CT equals to AC cos of, I can represent it as 2 pi FCT plus 5. Clear? Now, in the case of amplitude modulation, phase is constant. So no need to represent phase everywhere. So I can represent the carrier term as CT equals to AC cos 2 pi FCT. Is that clear? So after amplitude modulation, the constant amplitude of carrier signal varied according to changing of message signals. Okay, the amplitude of carrier signal will change according to modulating signal. Is it clear? So here in this point, the amplitude is higher. So accordingly, we will get the maximum amplitude of modulated signal in this point. Is it clear? Now here the amplitude of message signal is lower. That's why in this point we will get the amplitude of message signal low. Is it clear? Here the amplitude of message signal is 0. So at this point, what we will get the amplitude of carrier signal as 0. Always the modulated signal consists amplitude, and it is the amplitude will be AC plus A. So here in this point, its amplitude is AM, its amplitude is AC. That's why we will get the amplitude as AC plus A. Here the amplitude is AM, and here the amplitude is minus AM. Is it clear? Here the amplitude is minus AM, and here the amplitude is plus AC. That's why we will get the amplitude as AC minus AM. And because the amplitude of carrier signal is high as compared to amplitude of message signal, so we will get the amplitude in the positive direction. Is it clear? And in this point, the amplitude of message signal will be 0, and the amplitude of carrier signal will be AC. So what we will get the amplitude of modulated signal? AC. Is it clear? So when we represent the modulated signal, so modulated signal will look like somehow this way. Modulated signal will look like somehow this way. Is it clear? Okay. So this one is the highest amplitude, AC plus AM. This one is AC, and this one is AC minus AC. Is it clear? Okay. So this one is all happening in the case of amplitude modulation. But in the case of frequency modulation, we know that this carrier signal consists of constant frequency FC. This carrier signal consists of constant frequency FC. But in frequency modulation, we know that which parameter of carrier vary? Frequency of carrier signal vary. It means that this FC will vary according to message signal. Is it clear? This frequency will vary according to message signal. So when this frequency will vary, so definitely we will get a new frequency. So the after the variation of carrier frequency, the new after the variation of carrier frequency, the new frequency that we will get is known as instantaneous frequency. Is it clear? And the difference between instantaneous frequency and the carrier frequency is known as frequency deviation. Is known as frequency deviation. Suppose you consider numeric examples such as before modulation the frequency of carrier signal is 100 hertz. Before modulation the frequency of carrier signal is 100 hertz, and after modulation this 100 hertz will change into 120 hertz. Okay, so 120 is the instantaneous frequency. 120 is the instantaneous frequency, and 100 is the carrier frequency. 100 is the carrier frequency before modulation, and 120 is the carrier frequency after modulation. So the after modulation, the new value of carrier frequency is always known as instantaneous frequency. Is it clear? And so the difference between instantaneous frequency and the carrier frequency is known as frequency deviation. Okay, the difference between instantaneous frequency and the carrier frequency is known as frequency deviation. इतना क्लियर है सभी आप लोगों को? ठीक है? Okay, so the instantaneous frequency is represented as Fi. The instantaneous frequency is represented as Fi. Carrier frequency is represented as Fc. Wait a while. Carrier frequency is represented as Fc, and the difference between instantaneous frequency and the carrier frequency is known as frequency deviation. It represents how much our frequency will deviate, due to the variation in modulating signal. Is it clear? Okay. Note down, note down, note down our new unit. Note down our new unit. जितने भी स्टूडेंट अभी ऑनलाइन प्रेजेंट बेटा एक बार अटेंडेंस दीजिएगा. In next unit, note down frequency modulation. Note down frequency modulation. Heading subheading frequency modulation. Frequency modulation is a process. Frequency modulation is a process. Frequency modulation is a process in which which parameter varied? Very good. In which frequency of carrier signal varied. Frequency of carrier signal varied according to modulating signal. And at that time other parameters that means amplitude and phase are, and at that time other parameter that means amplitude and phase are constant. Amplitude and phase are constant. Clear? Okay. Paragraph change. Yeah. New subheading. Phase modulation. Next subheading. Phase modulation. Phase modulation is a process. Phase modulation is a process. Phase modulation is a process. Phase modulation is a process in which phase of carrier signal varied. Phase of carrier signal varied according to modulating signal. Phase of carrier signal varied according to modulating signal. And at that time other parameters that means amplitude and frequency are very good. Amplitude and frequency are constant. Paragraph change. frequency and phase, the combination of 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 frequency and phase is known as, the combination of frequency and phase is known as angle. The combination of frequency and phase is known as angle. That's why these modulation comes under the category of, these modulation comes under the category of angle modulation. Under the category of angle modulation. Under the category of angle modulation. Now the waveform for frequency modulated signal. Now the waveform for frequency modulated signal. First we have to draw the maximum signal, then accordingly draw the carrier signal. Draw it first, AC minus AC. Please check here. Here I am drawing the frequency modulated signal. In frequency modulated signal, the frequency of this carrier signal will vary. What is the frequency of carrier signal before modulation? Before modulation. Yes. AC. Frequency of the carrier signal. FC. The frequency of carrier signal is FC. After modulation, this FC will vary. Amplitude? Same. Amplitude will be same. Okay. So here in this point, the amplitude of massive signal is higher. So that's why the deviation in this carrier frequency FC will be higher in this point only. Okay, here the amplitude of massive signal is higher. So when we modulate carrier signal, when the frequency modulate carrier signal with this massive signal, so at this point the deviation in this carrier frequency will be larger, will be highest according to massive signal. And in this point, the amplitude of massive signal is lower. That's why in this point, the deviation in this carrier frequency will be lower. Is it clear? Okay. So I am representing the deviation as delta. So what we will get after deviation? From this point, from this point to this point, amplitude is high, amplitude will be in the increasing mode. So that's why the frequency of carrier signal from this part to from this end to this end will be in the increasing. So in the increasing order. So if the frequency in this point is FC, so here the frequency is FC plus somehow I am assuming is 10 hertz. Then in this point it is 20 hertz, then in this point it is 50 hertz. In this point, the deviation will be high. So when the frequency is increasing, so to represent the increasing frequency, we will represent the compressed waveform or we will represent the expanded waveform. To represent the higher frequency, we will represent the compressed waveform or expanded waveform. Compressed waveform. That's why I am representing a compressed waveform from this result. Because here the frequency is higher, frequency will be increasing continuously. So that's why in this part, from this part to this part, I am compressing this carrier signal. Okay, now from this end to this end, the amplitude will continuously decreasing. That's why from this end to this end, the frequency of carrier signal will be in the decreasing mode. So because the carrier signal will be in the decreasing mode, so that's why to represent that carrier frequency, we will represent it by using expanded mode. So the waveform will be now the waveform will be now here you can see the difference between these two waveforms. Here this represent the higher frequency, this represent the lower frequency. Now from this point the amplitude will be continuously increasing. So to represent this continuously amplitude in the terms of frequency, we will use compressed waveform. So here again I am using a compressed waveform. Is it clear? So this one is the frequency modulated signal. Is it clear? So I am representing the carrier signal as CT, I am representing the massive signal as MT, and this one is the modulated frequency modulated signal. I am representing it as S. Note down, this one is the modulated signal, this one is the modulated signal plus AC. Why the amplitude of modulated signal? Why the amplitude of modulated signal? Why the amplitude of modulated signal is represented by plus AC or minus AC?
Sir, because amplitude modulation frequency modulation.
Very good. Because in the case of frequency modulation, the amplitude will be constant. That's why the amplitude will be the plus AC minus AC. Note down. Okay, now note down the mathematical expression. Now note down the mathematical expression to calculate the frequency division. First, look here. This one is the expression. This one is the expression of carrier signal in terms of angles. We are representing the angle in terms of frequency and phase. So here I am taking the angle, this angle in terms of frequency and phase. Now I differentiate this angle with respect to t. So here I get the d theta by dt, and when I differentiate it with respect to t, so this t will cancel out, and we will get the 2 pi fct, the 2 pi fc, and here d phi by dt. Okay, so now this d theta by dt is known as the instantaneous frequency. This d theta by dt is known as instantaneous frequency. So I am representing it as omega. Okay, so this omega can be written as omega equals to omega c plus d phi by dt. Okay, now I am representing this omega in terms of fi, and we know that omega equals to 2 pi f. So this omega can be written as 2 pi into fi. Same as this omega c can be represented as 2 pi fc. Okay, so when I am taking 2 pi as a common part, so what I can write here, fi equals to fc, and this 2 pi will be transferred in the denominator part of this d phi by dt. So what we will get 1 upon 2 pi d phi by dt. Now this term 1 upon 2 pi d phi by dt is known as del f, that is frequency derivation. Accordingly we can say this instantaneous frequency we will get by adding the frequency deviation with this carrier frequency. Suppose I am considering the starting frequency before modulation as 100 hertz, and after modulation the carrier frequency will be 120 hertz. So 120 will be the instantaneous frequency. Starting frequency will be the carrier frequency. Starting frequency, carrier frequency will be 100 hertz. So 120 hertz minus 100 hertz equals to 20 hertz. So this 20 hertz is the deviation of frequency, that is changing the frequency due to the changing in the amplitude of modulating signal. That's it. Okay, no doubt, no doubt, no doubt this part. सिर्फ 4 स्टूडेंट ऑनलाइन मुझे दिख रहे हैं, लेकिन अटेंडेंस सभी की आ गई है, ऐसे कैसे पॉसिबल है? 1 2 3 4 5 6 7 8 9 10 10 students already given their attendance, but only 4 are online now. 19 students are there. Akash, are you present now? Akash, Archespata, गौरव प्रेजेंट होगा, मैं श्योर हूं. मयंक, सुरभि, ठीक है गौरव, मुझे पता है आप प्रेजेंट हैं. अभी नहीं हो सकता, फोर्सफुली भी है ना, किसी को कॉलेज आने के लिए नहीं बोला जा सकता, अभी गवर्नमेंट से ऑर्डर. यहाँ तक समझ में आया आप लोगों को, है ना? इसको नोट करके रखिएगा. Fi equals to Fc plus okay, check. So what we can write here? We can write Fi equals to so we can write Fi equals to Fc plus del F. No doubt. First look at here. This Fi instantaneous frequency will be maximum in the case when we get the maximum instantaneous frequency. When we will get the maximum instantaneous frequency. By using this expression, tell me when we get maximum instantaneous frequency. So we samne dekho. When we get the maximum instantaneous frequency, that's it.
Sir, जब AM भी high होगा और FC को
by using this expression only. FC जब maximum होगा.
सर जब AC plus AM होगा तब maximum frequency आएगा.
Good, but I am asking about by using this mathematical expression only. सब लोग सब सही बोल रहे हो.
सबसे ज़्यादा
When we will get the maximum Fi.
सबसे ज़्यादा
जब when frequency deviation is 0. So when frequency deviation is I am asking when I will get the maximum instantaneous frequency.
तो वेरिएशन से जब ज़्यादा होगा. Yes sir. I see.
क्यों इसमें क्यों ये
वो भी मतलब हाई हुआ और ये भी हाई.
भाई लोग की नहीं. देखो बेटा, अभी फ्रीक्वेंसी मॉड्यूलेशन जब स्टार्ट किया था तो मैंने क्या बताया था सुमित? तो उस समय मैंने बताया था कि हमारी फ्रीक्वेंसी चेंज होती है और जितना चेंज आता है उसके अकॉर्डिंग इंस्टेंटेनियस फ्रीक्वेंसी मिलती है ना? तो जो कैरियर फ्रीक्वेंसी बीटा वो कांस्टेंट रहती है, उसके अकॉर्डिंग किस में चेंज आता है, उसके अकॉर्डिंग जो चेंज आता है उसको हम लोग कहते हैं डेविएशन. तो ये तो भाई कांस्टेंट है, तो जब इसमें ज्यादा चेंज आए तो ये ज्यादा मिलेगी, जब ये कम होगी तो ये कम होगी। बात समझ में है? जब इसकी वैल्यू +20 हो जाएगी तो हमें यहाँ पे ओवरऑल 120 मिल जाएगा, जब इसकी वैल्यू -20 हो जाएगी तो हमें यहाँ पे 80 मिल जाएगा। बात समझ में? इसमें क्यों नहीं चेंज, इसलिए इसमें क्यों नहीं हम लोग बात कर रहे हैं, क्योंकि ये तो कांस्टेंट है। Clear that? So it means that we will get the maximum instantaneous frequency I have written as Fi max. Okay? Maximum instantaneous frequency equals to Fc plus del F max. Clear? I can represent it as Fc plus del F only. When I will get the minimum instantaneous frequency? When I will get the minimum instantaneous frequency? When the frequency derivation is minimum. So I am representing it as del F minimum. Del F minimum I can write del F minimum as minus of del F. अब ऐसा मैं क्यों बोल रहा हूँ, ध्यान देना। ऐसा मैं क्यों बोल रहा हूँ, ध्यान देना। This one is this one is the method signal. Its amplitude in the positive side as well as its amplitude in the negative side is same. अगर मैंने पॉजिटिव साइड में अगर +5 के नेगेटिव साइड में मैं -5 करूं, इसका मतलब ये है कि if I get the maximum if I get the maximum frequency due to +5, so I will get the minimum Fi in the case of -Fi. Is it clear? When the deviation, when the carrier amplitude of carrier signal varied both sides, when the distribution of the carrier amplitude is similar in both the sides, that is positive side as well as negative side, at that time we will get the value of the frequency deviation same in the positive as well as in the negative side. Okay, so I can represent this del Fi minimum as Fc minus of del F. Is it clear? But in the second case, if the variation in the positive side and the variation of the negative side is not similar, so at that time the value of this plus del max and minus del min will be the different. Okay, is it clear to all of you? I am taking here the ideal case. That's why I have written plus del F and minus del F. Okay, so I am considering this equation as equation number 1. I am considering this equation as equation number 2. So when I am adding the equation number, when I am subtracting the equation number 1 with the equation number 2, so what we will get? I am subtracting the equation number 1 with the equation number 2. So what we will get? We will get Fi max minus Fi min. Fi max minus Fi min equals to 2 del F. Is it clear? So this 2 del F, this 2 del F is known as, no doubt, this 2 del F is known as carrier swing or frequency swing. Is it clear? So if in an exam the frequency definition is given and someone asks you what is the value of frequency swing, so what is the value of frequency swing? Twice of del F. If the deviation is 20 hertz, so what is the value of carrier swing or frequency swing? 40 hertz. That's it. No. Fi max minus Fi min equals to twice del F. प्रांजल प्रेजेंट है आप? अभी मुझे सिर्फ लाइन में 3 लोग दिख रहे हैं. ओके, आई एम टेकिंग, आपने सभी ने नोट कर लिया बेटा, इसके बाजू में नोट कर लीजिएगा. दिस 2 del F is known as carrier swing. Okay, this 2 del F is known as carrier swing. Del F is known as Fi is known as define the frequency deviation.
Difference between instantaneous frequency and carrier frequency.
Very good. Mathematically, we can say frequency deviation is the difference between instantaneous frequency and the carrier frequency. In other words, we can say the maximum change in the carrier frequency. The maximum change in the carrier frequency. समझ में आ रहा है? This one is the 120, this one is the 100. 120 is the maximum change. The maximum change in the carrier frequency due to the modulating signal is known as frequency elevation. Is it clear? Okay. Or what is the value? What is the instantaneous frequency? How much carrier frequency is changed according because of the changing in the modulating signal is known as instantaneous frequency. जितना भी change हो रहा है धीरे धीरे, है ना? डेल एफ हमेशा मैक्सिमम और मिनिमम की बात होगा, जैसे जैसे चेंज होगा ना बेटा उसको हम इंस्टेंटेनियस फ्रीक्वेंसी कहते हैं, है ना? चलिए ओके, या आई थिंक यहाँ तक क्लियर है सबको, ठीक है? इसका बाद का हम लोग फिर कैरियर स्विच तक अभी कर लिया, इसके बाद का जो भी डेरिवेशन हम लोग अगले लेक्चर में करेंगे, ठीक? आई थिंक जितने भी स्टूडेंट्स मेरे ऑनलाइन में प्रेजेंट है सभी को क्लियर है क्या? जितने भी स्टूडेंट प्रेजेंट है, अर्चस्मिता, गौरव, मयंक, सुदीप, आदित्य, अभय, निर्भय, आकाश, एवेंजर्स फन क्लब, सभी को क्लियर है बेटा? ओके, थैंक यू सो मच, थैंक यू सो मच।